From the dawn of civilization, humanity has shared one relentless ambition: to build bigger, to defy the laws of nature and leave a mark that outlasts empires. We built cathedrals that soared to the gods and bridges that spanned impossible gaps. Each generation has its own pyramids, its own wonders. But as we stand at the threshold of a new technological age, we must ask, what is next for humanity? What are the megastructures that will define our future? In this documentary, we explore 5 visionary engineering projects that are so audacious they seem like science fiction. These are the megastructures that will redefine our civilization. Our first megastructure tackles one of humanity's greatest challenges: escaping Earth's gravity. For over 60 years, our only method has been this: controlled explosions. Rockets are violent, inefficient, and incredibly expensive for every kilogram they lift. But what if there was a gentler, cheaper, and more elegant way? Enter the space elevator. The concept is simple in theory, but monumental in scale. A super strong ribbon or cable stretching over 35,000 kilometers from the surface, all the way to a counterweight or space station in geostationary orbit. No more rockets. Instead, robotic cars or climbers would ascend the ribbon. Quietly, efficiently, powered by electricity or even lasers beamed from the ground. So if the idea is so brilliant, why haven't we built one yet? The answer lies in one immense engineering challenge: the cable itself. No known material, not even the strongest steel, is strong enough to support its own weight over that distance. At least no material until now. Enter the age of nanomaterials, specifically carbon nanotubes or graphene, a material made of pure carbon with a tensile strength 100 times greater than steel at just a fraction of the weight. If we can mass produce this material, the elevator becomes possible, and the benefits are revolutionary. The cost to send anything to orbit would plummet from tens of thousands of dollars per kilogram with rockets to potentially just a few hundred. Space would finally become affordable. It would become a true highway to the stars, opening the door for industries like asteroid mining and massive solar farms in space. Once we have a highway to space, a civilization's next great challenge emerges: a thirst for energy. All life on Earth is powered by one single magnificent fusion reactor, our sun. But we only capture a tiny, infinitesimal fraction of its total power output. In 1960, the brilliant physicist Freeman Dyson asked a very bold question: what if a truly advanced civilization could capture all of it? This is the concept of the Dyson sphere, a hypothetical megastructure that completely encloses a star like a shell to absorb 100% of its unimaginable energy output. But it's not really a solid shell, which would be gravitationally unstable and likely collapse. The more realistic and popular concept is known as a Dyson swarm. Instead of a shell, imagine a massive, dense cloud of independent orbiting structures, trillions of solar collectors and habitats, each one capturing a piece of the star's energy. The scale of such a project is almost beyond human comprehension. To build it, a civilization might need to dismantle an entire planet for raw materials, feeding its resources into self-replicating robotic factories that build the swarm. But the reward for such an immense effort would be godlike power. It would elevate a civilization to a Type 2 on the Kardashev scale. A Type 2 civilization becomes a true master of its solar system. With near-limitless energy, interstellar travel and planetary engineering become possible. And that's why astronomers are looking for them. A Dyson swarm would be the ultimate sign of advanced intelligent life. While some look to the stars for humanity's future, others look to the vast, untapped frontier right here on Earth. Over 70% of our planet's surface is water. Meanwhile, our land is becoming overcrowded and our coastlines are threatened by rising sea levels. This leads to a radical idea. If we're running out of land, why not live on the water? This is the vision behind our third megastructure, permanent floating ocean cities. We're not talking about simple houseboats or cruise ships. We're talking about massive, self-sustaining communities designed to be home to thousands of people. Designs range from massive, interconnected hexagonal platforms to pyramid-shaped arcologies that can withstand even the most powerful ocean storms. These cities would be designed to live in harmony with the ocean, not to conquer it. To be truly independent, these cities must generate their own power from their environment. They would harness the immense power of the ocean itself using wave energy converters and cover their vast surfaces with solar panels to capture the endless sun. Food would be grown vertically in hydroponic farms and below the surface in large aquaculture pens. Fresh water would be produced through advanced desalination plants, turning seawater into drinking water. This creates a truly resilient civilization, completely immune to earthquakes, and safe from tsunamis, simply riding over the massive waves. Beyond survival, these cities offer a radical social experiment. The concept, known as seasteading, could allow for new types of governance and societies to form. While it may still seem like fiction, projects like Oceanic City have already been proposed to the United Nations. For centuries, crossing the vast Atlantic Ocean was a long and perilous journey. Then came the age of flight, shrinking the world and connecting continents in just a matter of hours. But what if we could connect them even faster? What if you could travel from New York to London in about 1 hour? This is the audacious dream of our fourth megastructure, the transatlantic tunnel. A tube over 5,000 kilometers long, connecting North America and Europe across the ocean floor. But this is no ordinary train tunnel. Inside, there would be a near-perfect vacuum. This would allow special magnetic levitation trains, or vac trains, to travel at speeds of over 8,000 kilometers per hour, free from air resistance. A journey that takes 8 hours by plane would now take less than 60 minutes. But building this is arguably the most difficult engineering project ever conceived. First, the immense water pressure at the bottom of the Atlantic Ocean. The pressure is strong enough to crush a modern military submarine like a soda can. The tunnel would need to be made from materials far stronger than anything used today. Then there's the construction. The tunnel would likely be assembled in prefabricated sections and lowered to the seabed by a fleet of autonomous robotic submarines. But the biggest challenge is geology. The tunnel must cross the Mid-Atlantic Ridge. This is an active volcanic zone where tectonic plates are literally pulling apart. Our final megastructure doesn't conquer space or the oceans. It tries to solve the biggest problem here at home. Our cities grow horizontally, consuming forests, farmlands, and natural habitats. This creates pollution, endless traffic, and a massive environmental footprint. But what if a city didn't have to grow out? What if it could only grow up? This is the idea behind the arcology, merging architecture with ecology. An entire city, potentially home to millions, contained within a single massive structure. It would contain everything: residential apartments, offices, shopping centers, and even massive indoor parks and vertical farms reaching up into the clouds. Transportation would be entirely internal, with high-speed elevators and monorails. The car would become obsolete. The land below could be returned entirely to nature. The space elevator, the Dyson swarm, floating cities, the transatlantic tunnel, and the arcology. These are more than just science fiction dreams. They are the potential answers to humanity's greatest challenges. A roadmap for our survival and evolution as a species. From reaching for the stars to mastering our own planet, these megastructures show the incredible power of human imagination. The future is not yet written. It will be built by the dreamers and engineers of today. So we ask you, which of these futures would you want to live in? Let us know your thoughts in the comments below. To explore more of what's possible, subscribe to Viral Vortex. And as always, stay curious.